Going to discuss about replication of DNA. Okay, so first we will see that the little bit introduction of DNA. So basically DNA, what is DNA? DNA is a polymer. Polymer means the compound or a substance like object that is made up of two or like more than two or more monomers. Okay, so DNA is a polymer and its monomer means polymer is made up of a monomer. So the name of the monomer is and monomer is nucleotide. So we'll see later that what is nucleotide and what's like how the DNA is made. So let's see DNA. What is nucleotide? Nucleotide is like a structure is made up of one like sugar and nitrogenous bases and phosphate group. So there is another terminology that is known as nucleoside. What is nucleoside? So nucleoside is like from nucleoside the nucleotide is formed. Nucleoside is made up of one sugar and nitrogenous bases. When we add phosphate group in nucleoside, so nucleotide will form. Okay, so now we're gonna discuss that what is nitrogenous bases and what is like the sugar in the structure. Nitrogenous bases. Nitrogenous bases are of two types. Basically, they are made up of organic compound and they are formed by the carbon and nitrogen. Their composition include carbon and nitrogen. Okay, so nitrogenous bases are of two types: purine and pyrimidine. Okay, purines and pyrimidine. So what is purine and what is pyrimidine? Let us discuss. So you need to keep that in mind that purine always form double bond. Not double bond, yes, double bond, but like double bond, and it create a single ring or a single bond, contain single bond. Then again, purine is classified into two more types, that is adenine and guanine. GY. Please check out the spelling. Yes, adenine and guanine. Okay, and the pyrimidine consists of again two nitrogenous bases, that is thymine and cytosine. So what are the conditions in the DNA, like who is gonna made like these four nitrogenous bases are gonna make the bond with each other. So there is the rule that adenine always form the bonding with thymine and guanine always form the bond with the cytosine. The bond between the adenine and thymine is always double bond. Okay, and the bond between the guanine and the cytosine is always triple bond. Okay, these are like some basic point of view of the DNA. And DNA is a double helix structure. If I could make like here, for example, here adenine is present, so here will be thymine. Here, if like the cytosine is present, so here will be guanine. If here like adenine again is present, then thymine, or you can adenine, add thymine. So as they are making bond with each other, so the structure or like will be this in the DNA will be same, like adenine. In front of adenine there will be thymine, as you can see. In front of guanine there will be cytosine. So this is how they make the structure of the DNA. So now let us discuss about our main topic, the replication of DNA. So I'm gonna give again a little bit more information. So from DNA to RNA, the process by which DNA made RNA is known as transcription. Okay, and the process by which RNA made protein is known as translation. So our topic is replication of DNA. Where is the replication of DNA? Means the DNA forms its own copy is known as replication of DNA, and here the information are being transferred, like the flow of information from DNA to RNA, RNA to protein, and protein will decide that how do you look like. Protein will decide your complexion, protein will decide your height, your weight, your eye color, everything. So this flow of information is known as central dogma. Okay, so what DNA contain and how, like the way you look, your complexion. So DNA contain genes, a little like structure that are present in the DNA contain genes. So these genes will decide how do you look, what's your composition, what your face color, what your like height, your whatever weight. Or you can say that gene is the unit of DNA. So now let's go through the main topic, that is DNA replication. So like see, as I told you that DNA form is in the form of double helix structure. Means this is the strand, this is one strand. As I told you that DNA is made up of double helix structure. These are the nitrogenous bases. You have adenine, cytosine, then adenine, thymine, and in front of that thymine, guanine, thymine, adenine. So like this, in this form the chain will be continued. So here the real replication will start. How? Let's see. This is the strand of DNA. Here another strand, here two strand will join. For this strand will join, and for this here another strand will join. So if we'll see this clearly, these like, if I could make it in the broad manner. So here for this template, this strand, another strand will come and join. And for like, first of all, these both were from these old strand, a new strand is forming, a new strand will come and form. You can see from this old strand, these both old strand, another strand is coming and making a new strand. So this is known as semi-consecutive DNA replication. Conservation DNA replication. Okay, means from an old strand the new strand is forming, that is known as semi-conservation DNA replication. So here many enzymes are gonna work that are gonna produce more strand. Like now the replication is gonna be here. So let us make the diagram over here. Okay, it requires time. So yeah, now here a enzyme will come and will work on. That enzyme is known as A protein enzyme. A protein enzyme will come, like it's the structure, these are its hook. So A protein enzyme will come and it will work on these strands. So what it gonna do, it gonna open these strands more. So this is a protein enzyme that is gonna break the the strands, and where it will work and the bonding between adenine and thymine. Why? Because they contain the double bond, and there is more easier way to break down the bond between thymine and adenine, because they contain the double bond rather than the triple bond. So the part where they will separate the strand is known as place of origin. This is known as place of origin. Okay, now let's go through. So now if you could see that after the separation, after the work of A protein, how the DNA is formed. So the DNA will be formed in this bubble like structure, because we have broken DNA with A protein by these hooks. DNA protein broke these strands, so it will be in the form of this. Okay, so this is known as replication bubble. Now this is a single strand and this is a double strand, single strand. So like in the condition, there is a possibility that they can join. To separate them, here is an enzyme work that is known as SSB. To separate these, like they can, like in a condition, if they are going to join again, so there must be a enzyme that stop from joining them. So that enzyme is known as single strand binding protein. What they're gonna do, they're gonna start from the binding of the strands. Okay, so now if we're gonna see the transverse section of this replication bubble, so it's gonna be more easy to explain. So we're gonna make the replication fork. Okay, this is the replication fork. Okay, so now here for more replication, another enzyme will work, and the enzyme name, that is very efficient enzyme, that enzyme name is polymerase. Okay, that is DNA polymerase. So now DNA polymerase is a very efficient enzyme, as I told you. So like it, wait, let me say what is happening. Okay, so like it have some condition, and the another name for DNA polymerase enzyme is DNA dependent polymerase enzyme. Why this is called DNA dependent polymerase enzyme? Because here the enzyme, this polymerase is working on DNA. If this polymerase will be working on RNA, so this enzyme can called RNA dependent polymerase enzyme. So it always work on 5' to 3'. This is like 5 to 3, and here 3 to 5. It always start its work from the 5 dash to 3 dash, but it have some condition. It always said that I will work on the single strand, but it required like he always says that I required the origin where I will work must be double bond. So like in one way he is saying that it is gonna work in the single bond, but a single strand, but it needs the double bond, or sorry, double strand for its origin. So here another enzyme is gonna work that is made. The strand is known as primase. Primase. Okay, so primase will make deep strand. Okay, so that polymerase can work. Like here A, T, C, G, and this the opposite of 3 means 5 dash to 3 dash. As I told you, I always work on 5 dash to 3 dash. So this is how the primase. Let us discuss more about the primase. That primase is a piece of RNA. It is a piece of RNA. What were the condition of polymerase? DNA dependent DNA polymerase. Let me write here DNA dependent DNA polymerase enzyme. So what it gonna do, like there are a few conditions that it always work on the single bond, but the origin where it gonna work must have the double strand. So this is the double strand, so primase will work here. This is a piece of RNA that will make a strand just for like to like it will always make to make DNA dependent polymerase happy. So it will make the what do we say, strand, but it always stop here. Why? Because it always work at the fork. Okay, so here to cut that fork, another enzyme will be coming that will be in the another part of this video, so we're gonna see. So here like means the strand is forming. So this is how the DNA polymerase enzyme will work. So I'm gonna tell you more about it. As I told you that it is a very like efficient enzyme. What it do, it makes 4.8 into 10 power 6 base pairs, and in 18 minutes. Like see, you can see that it is a very important enzyme. It makes 1.8 into 10 power 6 base pair in 18 minutes, and its speed is about 2000 meter base pair per second. So it is a highly effective and essential enzyme that always work on the single bond, and it starts from 5 dash to 3 dash. You can see always work on 5 dash, from 3 dash make from 5 dash to 3 dash.